Hello and welcome to this new video. In this one we are going to deal with different parametric families. That is another type of families that is quite useful, especially if you are a family provider or if you are a manufacturer and you are selling your product in a bin format. So this is quite interesting. For this example, we are going to use a foundation pile, the same or quite similar to the foundations that we have used in our previous video. However, this is not a pre-default or a default family loaded by Revit. This is a new one. So I have just this is a family that we have already done. It's a parametric family, and we just have clicked in the file to open in our Revit environment. So remember that we are using RFI, so this is a family, and later we are going to export it to our RVT, what is a project. So we are not still in that part, we are into the family RFA part. We have not exported still this to a project. We are going to do this in the video. So why is interesting this parametric design? Well, what happens if, for instance, I have implemented in my model different foundation piles and I need to define different lengths, different distance to different parts of this is like a floor view, floor plan view. What happens if I need to define different heights, different depths, different distance for this building element? So do I need to open the family, click, modify the extension, close the family, upload to the Revit project again? So this is a quite hard work, especially if you have to go one by one element. So what is the solution for that Revit is providing? Is the parametric of the parametrization or parametrization of different elements. So how we can deal with this? Well, in this example we are going to, or we have already, I am going to explain which are the steps. We have parametric different things. For instance, we have parametric this thickness, we have parametric, or this is a parametric element. Well, in this family we have implemented a parametrization for this thickness, this height, this depth, the material for this extrusion and this extrusion, and we have also make a parametrization of the diameter of the foundation pile. Why is this important? So let's imagine that I have this pile, this foundation pile, and of course I want that my diameters always be inside of this. If I put the diameter totally free, or the radio or the diameter, I can, or the user, the final user of the family can create this foundation diameter that it has not sense. So the important thing here is to make a conditional parametrization. So in this regard, we have this foundation pile, and we are going to assume, for instance, that I want a maximum distance between the external line of the foundation pile and the interior part of the radio. So let's imagine that, for instance, this parameter should be the side, this parameter should be the radio, and this parameter is like a thickness, th I am going to call it, and I want always to keep this distance or this radio under those limits, this one and this one. So what is the equation that I need to apply? The side should be always bigger than 2 times the radio plus 2 times this thickness. So for this example, let's imagine that the minimum thickness that I want here is 0.2 meters, what it means 20 centimeters. The same here, 20 centimeters. So in this regard, it could be defined as 2 times the radio plus 0.4. The side should be bigger than this. So I want to make a condition to provide new values for the radio because I don't want to modify the side. I just want to limit the maximum radio. So the parameter radio should be, I will put in another color, the radio should be always less than the side minus 0.4 divided by 2. So this is the equation that I am going to define for this parameter, the radio. The rest of the parameters, like the side, like the depth of the pile, they are going to be totally free, as we can see right now. So now we are going to go to this part to see the parameters of the family. And as you can see, we have the thickness, we have the side, we have the length and the width, that they are default values that we are not using this. So the most important are this one. The thickness, the side, and the depth, and also the radio. And as you can see, we have two radio parameters. Why? Because one radio parameter will be the one that the user is going to input. So the user probably is going to define a radio of 1.2 meters or a radio of 10 meters. Of course, this will be, depending on the site, this will be correct and probably this will be incorrect. And how I apply the condition with the other parameter. So that's why there are two parameters. The radio one, for instance, radio foundation pile, that is this one, and the radio auxiliary. So this will be the radio auxiliary, that is the one that the user is implementing into the Revit project. Later, with the condition, we are going to filter the correct value and then we are going to assign the correct value to the real radio of the foundation pile. So where is the condition? As you can see, is in this part. I'm going to expand this and this. This is the condition. So it's like a condition in the spreadsheets in Excel. As you can see, it's a simple if context or if formula in which the first item is the condition if 2 times the radio, the auxiliary radio, is less than the side minus 2 times the thickness. If it happens, the radio will be the auxiliary radio, because what is happening? This condition, if it happens, the radio implemented by the user here is correct. So if it is correct, as you can see, we are providing the same value to this part. What happens if not? If I put, for instance, here, I am going to do it right now, if I put 10 meters, the equation of side should be always bigger than 2 times the radio plus 2 times the thickness. It's not going to be correct. So this maximal value is not correct for the radio. So the new value of radio, what will be? The radio will be equal to side minus 2 times the thickness divided by 2. So if the auxiliary radio provided by the user fulfills or is correct according to these conditions, we are going to provide the radio of the user. However, if not, we are going to provide a new value of the radio according to this formula. So as you can see, if I put 0.5, well, it fits, the radio is correct because I have a total side, as you can see here in this parameter, of 3. If I have a parameter at 3 meters, 3 meters minus 2 multiplied by 0.2, it's 3 minus 0.4, it means 0.6 divided by 2, 1.3. So if the radio is less than 1.3, is correct. If not, if it's bigger, we are going to provide another value of the radio. Which one? 1.3. Why is 1.3? Because I am using this side. If I change this side, it will be another. Okay? If instead of 3 meters, we are using 6 meters, the minimum radio or the maximum radio, will be 2.6. So imagine now we are in the context in which the maximum radio is 1.3. Let's try to put 1.9. If I click outside, I can see that this value goes to here and then it goes to here. 1.9 is bigger than 1.3? Yes, it is. So that's why the maximum value is 1.3. And this is totally automatically. If I change the side, for instance, to 6, now I can see that, that the maximum value it's another one, and now the 1.9 meters of radio it's correct. Which is the maximum? Let's try to put 48, and now the maximum is 2.8. Okay, so this is a correct way to make all the different sides, all the different distance parametric. So it's quite interesting to put this menu in this side and try to see, okay, let's try to find a side of 3 meters, let's try to define a 0.5 of thickness, a total foundation depth, that is this distance, of 6 meters, for instance, side 3, this 0.2, and this radio, let's try to put 0.5. Apply, and as you can see, it's correct. If I put another radio, 10 meters for instance, it passes to the condition and it filters the correct value. So let's put another one, for instance, 1 meter. Okay, so one part of one important benefit of implementing these parametric values is this. You can apply different conditions according to different distance or according to different parameters. The other important thing is that I can provide an easier way to manage the family inside a project. Remember that we are not in a project, we are now in a family. So I am going to close it because I have the family created, and I am going to open a new project. New project, as we have done in previous video, I am going to go to the English metric, English default metric, I'm going to open, okay. I am going to create a 3D view, and I am going to this level 1. So how can I drop this family? I'm going to look for my family, and this is my foundation family, RFA. I am dropping into my RVT. This is my family, and I'm clicking this. As we have seen in previous videos, I cannot see the family according to the range of view. I'm going to click this in unlimited. We have explained in this menu in other video. Now I can see, and I am going to create different one. I am going to go to see in a 3D view. As we have said in the beginning of the video, what happens if I need this distance different from this one and different from this one and different from this one? Do I need to open the family, change the parameters, save the parameters, save the family, reload the family into the project? No. If the family has been implemented with parametric elements, it's not necessary. Where are the elements? If I want to, for instance, change this depth only in this element, I can click on it, and into the left part, what do I have? I have all the elements that the modeler of the family is providing to me. So I don't need to go to the family and modify the extrusion and modify the geometry. I can just go here and say, okay, let's change first the units. I have used the shortcut of UN, and I am going to change the distance to meters, 2 decimal places, this one also, meters, 2 decimal places, okay. And now I have, for instance, let's change the total depth, this parameter, and I want, instead of 10 meters, 6 meters. I change it, and I have changed inside the parameter, inside the model. I don't have to go to the family. Instead of this, I want this side quite bigger, for instance, and I want to 10 meters. And this one, I can put, for instance, another different thickness, for instance 2 meters, another depth, for instance 15, another side, for instance 6, and another radio. That, of course, the radio is conditioning according to the if parameter that we have already done. So why is so important? Because through the Revit parameters of the family, you can change all the properties of the family. You don't have to go manually to open the family, that should be executed through this part, and change all the geometry. That's why it's quite important, the implementation of the parameters or parametrization of elements inside of the Revit families. So that's all for this video. Hope you enjoy it, and see you in the next one. Thanks for your attention. This video and this mock is part of the project Digital Twins Infrastructure and Cities. You can find more information through this link and through this QR. Thank you very much for your time.